All right, today we're going to talk about using chords within our circles and some different properties that those chords will have within our circles. So the first one is looking at congruent corresponding chords. So if you're talking about the exact same circle here, and we have two chords that are congruent, then the minor arcs that they cut off, so arc AB and arc CD would also have to be congruent. So congruent chords equals congruent arcs within the same circle. It's going to be a big one that we're going to apply later. Another one dealing with the perpendicular chord. So if you have the diameter going through a diameter of a circle is perpendicular to a chord, then the diameter bisects it. So we are cutting through this chord, and we are going, if it's perpendicular, it will also bisect it. And so that's going to help as we have finished the chapter with right triangles. If we think about drawing in a radius, we now have a right triangle. So some of those things are going to come back into play. And then this one is just in the opposite direction. If it bisects, then it is perpendicular as well. So in this first one, circle P and circle Q, if FG is congruent to JK and the measure of this arc is 120. So while this isn't the same circle, because these radii are congruent, that means these circles are also going to be congruent to each other. And because we have congruent chords, that means we're also going to have congruent arcs. So the measure of arc FG is going to be 120 degrees. Again, going with congruent chords, it's going to equal congruent arcs, but it's because we also have congruent circles. In number 2, we cannot say that this arc is 90 degrees because of this. That is not true, because that is not a central angle. It's not at the center of the circle. So we cannot say that they are going to be congruent. But we can say because of perpendicular, we're going to have this chord and that part be congruent. We are going to have congruent arcs. So we can mention that 2x minus 8 is going to be equal to 127 minus x. And when we solve for x, we're going to get x is 45. Now we can use that to answer our two questions here. So in part A, we're finding the measure of KH. KH is a segment, so going along K to H, because this part is 14 and it's perpendicular, that means the other part is going to be 14, so it's going to equal 28. And then for HLK as the measure of the arc from H through L to K. I actually don't know either one of these arcs, but because I do know the measure of these two arcs, because I have an x value, I can subtract that from 360. So when I plug 45 in, 2 times 45 minus 8, I'm going to get 82 degrees for this arc and 82 degrees for this arc. So the measure of arc HLK is going to be 360 minus 82 and minus 82 to get 196 degrees. Another property that we're going to apply, and again, it's going to help with our ability to use right triangles. But if in the same circle or in congruent circles, if two chords are congruent, then they are equidistant from the center. So AB and CD are going to be congruent to each other if and only if they're the same distance from the center point of the circle. So in number 3, we are given the fact that they are both 12, which means that CD and AB have to be congruent. Because they're also perpendicular, we know that all 4 of those pieces are going to be congruent. Therefore, not only is AB equal to CD, but AP is equal to PB, which is equal to CQ, which is equal to QD. So 5x plus 7 is going to be equal to 7x minus 3. And I get x equals 5. So now the question is actually asking me find the radius. So draw the radius that is beneficial to us, and I'm going to draw the radius to create a right triangle. So I have a right triangle with a side length of 12. I'm looking for my R value. And when I plug in 5, I get 7 times 5 minus 3. I get 32 for that side. So now I can use my Pythagorean theorem. And then we need to simplify this, and you can pull out a 16. So a simplified radical form would be 4 square root of 73. So a big thing to know here, this kind of sums up what we're talking about with congruent arcs and congruent angles and congruent chords the last couple days. So here we have congruent angles in the middle, which is going to tell us that the arcs are the same. Over here is what we just talked about on the far right, where you have congruent arcs, which tells you congruent chords. So you can connect between all 3 of them now, that if you have congruent angles or chords or arcs, they will all tell you the other ones are also congruent. So applying that to a couple examples. First off, I have chords are congruent, which means my central angles must also be congruent, so therefore x is equal to 70 degrees. For number 5, because these chords are all congruent, that means the arcs must also be congruent as well. And then I also know that all of the angles in a circle all the arcs in a circle add up to 360 degrees. So 3k plus 70 equals 360. And I can just keep that in fraction form and get 290 over 3 degrees. All right, I would pause the video here to see if you can attempt to solve numbers 5, 6, and 7. We'll talk about 8 and 9 together, but if you can solve 5, 6, and 7, that would be a good checkpoint to see where you are at right now. So number 5, on one side it gives us AB is 15 minus x, and on the other side it's 2x minus 5. But because they are both 2 units from the center, that means the entire segment of AB, 15 minus x, is going to have to be equal to the entire segment over here on the right, which is 2x minus 5, but also another 2x minus 5 because it's cut in half. So I can solve this equation. and get x is 5, which can help me answer that question right there of CD, because each of these pieces are going to equal 5 now. So the length of CD is also equal to 5. Now the next question of finding the radius, just like we talked about before, we have right angles here, so let's draw a radius in a way that would help us. We have a length of 2, we have a length of 5. We can solve for the r value. So 2 squared plus 5 squared equals my radius squared. And we'll keep it as the square root of 29. For number 6, again, we have chords are congruent, which means arcs are also going to be congruent. So I'm going to get 130. We have a central angle right here. So this is y, which means my arc is also y. I now have all of the arcs in a circle. So that would mean that all of them must add up to 360 degrees. And I get that y is 80 degrees. Now for number 9, we need to actually recall a little bit about triangles. So if I highlight this triangle of PAB, because these are both radii, that means they are congruent, and because I have two sides are congruent, tell me that its opposite angles are also congruent. So I'm going to get 25 for that angle as well. Now all angles in a triangle have to add up to 180, so when I subtract 25 and 25, I'm going to get 130 for this angle, which is also a central angle, which makes this arc 130. Now I have two arcs that are missing. I don't know what they are, but I do know that they have to be equal to each other because the chords are equal to each other. So I call them both x, and then all of my arcs together must add up to 360 degrees. When I solve that, I get x is 82.5. Now I can go back and find the measure of all three of those arcs. And so the measure of arc AB is 130, and then we found the other two are both 82.5 degrees. Now the last